All right, so in these notes, we're going to be looking at graphing rational functions. And here we need to worry about, the existence of holes, asymptotes, things that I don't think we've had this many asymptotes in one set of graphs before. We've only been dealing with one. So these will have multiple. And then we have the concept of a hole. So we're going to go through first how to find each of these things, the holes and the asymptotes, and then look at what their graphs look like. So first off, a hole exists if a rational function has the same factor. It's going to look like, x minus b in both the numerator and in the denominator. So if that factor exists, and a lot of times we'll see it with parentheses around it, if that factor exists in both the numerator and the denominator, then the hole is going to appear at the point x equals b. And it turns out that's where the hole will be. However, that particular value x will not appear in the domain. So let's first look at this particular function here. We've got x squared plus x minus 6 over x minus 2. So what we need to do first is go ahead and factor it. That is going to be step 1. Something like, it was like, when in doubt, factor it out. Because we need to look for something of this form. We need to look for a linear factor. So we need to factor this thing out to see if there's anything common. So x squared plus 6 is factored out to, let's see, multiply to negative 6 but add to positive 1. So we've got x plus 3, and then x minus 2. And then in the denominator we still have x minus 2. So it does appear that there is a common factor here. These two things, these are going to divide to 1, and that will leave us with just x plus 3. What this means is there is going to be a hole. There's going to be a hole at x equals 2. So let's look at the graph of this. What will it look like graphed? Oops. That also noise in the background just happens to be my dog and my cat playing, if you can hear it. Okay, so now that we've got a grid, what this is going to look like is we are going to have the function x plus 3 for the most part, except for we're going to end up drawing that line x plus 3, but we're going to put a hole where x equals 2. So let's look at drawing that line x equals 3. We have a y-intercept at 3, and we have a slope of 1. So put in a couple points here to help us get a line. And then at x equals 2, we're going to put a hole. So that's going to be that spot right here, the point 2, 5. We have a hole there, and then we got a line outside of that. Okay, theoretically that line went through those points. But this is what the graph of this particular rational function looks like. And we need to know where the holes are, because a lot of times our calculators will not show us that. It'll look like it's a straight line going all the way through. When in fact, if we were to put in the value 2, it will have a 0 in our denominator over here, which means that the function is undefined at that value. Alright, so let's go on to our next set of stuff where we're looking at where the asymptotes are. We've got vertical ones, we've got horizontal ones, and Also, zeros, which is where the graph crosses the x-axis. Okay, so let's look at vertical asymptotes. Our vertical asymptotes, the main thing we're looking at in our vertical asymptotes is our denominator. Hold on, let me get my pen back. We're looking at our denominator, so that's going to be our q of x value. We're looking down here, and our vertical asymptotes are going to exist at any value of x where the function q of x equals 0. So we're going to have a vertical asymptote at that point. So right now we're just going to fill in some of these pieces and then go into what that looks like on the graph. So any value of x where the denominator equals 0. And then for zeros, we're going to be looking specifically at the numerator. So we're looking at this piece right now. Our zeros are going to exist at any value of x where p of x is 0. So we're looking where our numerator equals 0. And then finally, our horizontal asymptotes. Couple of different scenarios happening here. Notice that we're looking specifically at the degree. So we're looking for the degree of the numerator, and we're going to be looking at the degree of the denominator. And the degree, if we remember, it's like the value of the largest exponent ultimately. So if the degree of the numerator is greater than the degree of the denominator, it's kind of nice. That means there is no horizontal asymptote. If we go to the next part, if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is simply the equation y equals 0. And then finally, if the degree of the numerator and the denominator are equal to each other, then the horizontal asymptote is the line y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. Okay, so those are the rules.